Welcome to Brain Vision.
For part A of this question, we're asked to find all of the possible values for the angular momentum L. Well, the angular momentum L is determined by finding the value of the angular momentum quantum number little l, because they're related by big L being equal to the square root of little l times L plus 1. Well, we're told this is for the 3D of hydrogen state. Based upon the fact that we're told it's the D state, D gives us an L value equal to 2 by definition. So if L is equal to 2, then our angular momentum is equal to the square root of 6. So just replacing L with 2 gives us the square root of 6 times h bar. So that would be our solution for part A. To find all of the possible z components of the angular momentum number, we need to first find all of the values of m sub l. Well, the momentum quantum number m sub l is related to L. It can take on any value between negative L and positive L. So this goes from negative 2 to positive 2. So negative 2, negative 1, 0, 1, and 2. And our angular momentum z component value, L sub z, is just simply equal to m sub L times h bar. So this is plus or minus 2 times h bar, plus or minus 1 times h bar, which would just be plus or minus h bar, and 0. So we can box these in as our values for L sub z. And then finally, part C wants us to find the angles, theta. So the angle theta is related to the angular momentum and the L component of the angular momentum through the equation that says theta is equal to the inverse cosine of L sub z over L. So plugging in these different values, we can find these different angles. So for the negative 2 value, we'll just call this theta sub negative 2. This is equal to cosine, because it's going to be the same L value for all of them. So it's just the L sub z value that's going to be changing. And of course, the h bars are going to cancel. So this is just negative 2 divided by the square root of 6. Plugging those values in, we find a value for theta equal to 144.7 degrees. Next, we're going to replace L sub z equal to negative 2 with it being equal to negative 1. So we can maybe call this theta negative 1. So we take the inverse cosine of negative 1 divided by square root of 6. This comes out to be 114.1 degrees. And we're going to keep doing this for L sub z equals 0. So this is cosine, or inverse cosine, cosine to the negative 1. Did I write that on the one above? Yes, I did. Okay. So the inverse cosine of 0, which comes out to equal 90 degrees. Next, L sub z is equal to 1. So this is the inverse cosine of 1 divided by the square root of 6, which comes out to equal 65.9 degrees. And then the last one is when L sub z is equal to 2. So this is the inverse cosine of 2 divided by the square root of 6, which comes out to equal 35.3 degrees. Which we can box in as our final part of the solution to the question.